Welcome to EDU World Space.
In problem 86, we're given that an object and a screen are separated by 22 centimeters, and somewhere between them a lens is placed, and we're asked what two location of the lens will produce an image of the screen. And in part B, you have to find the magnification that's associated with each of the two positions. And we're given the focal length of the lens is 3 centimeters. So we'll use equation 34.16, which tells us that 1 over the object distance plus 1 over the image distance is 1 over the focal length. However, we don't know S and S prime, so this is S from the vertex of the lens to, or the center of this lens to the object, and this is S prime. So that's the distance from the lens to the image. So obviously from the figure, we have S plus S prime is equal to 22 centimeters. So what we can do by using this equation, we can eliminate, let's say, S prime, and then solve this equation in terms of S. So that tells me that S is 22 centimeters minus S primed. Or rather, S primed is 22 centimeters minus S. So if I substitute for S prime into equation 16, then I have one equation in terms of S alone. I have 1 over S plus 1 over 22 centimeters minus S is equal to 1 over 3 centimeters. We'll put the left-hand side over a common denominator. So this can be achieved by multiplying 1 over S by 22 centimeters minus S divided by 22 centimeters minus S. So this is just 1, so I haven't done anything funny here. And then this 1 over 22 centimeters times S over S, which is again 1, but as you can see, I'll have a common denominator. So that's equal to 1 over 3 centimeters. So then I have 22 centimeters minus S plus S divided by, I'll distribute this S, 22 centimeters times S minus S squared. That's equal to 1 over 3 centimeters. So then I have, if I just multiply crosswise like so, then I have 66 centimeters squared is equal to 22 centimeter times S minus S squared. And then I can move everything over to one side. So then I have s squared minus 22 centimeters times s plus 66 centimeters squared. And notice it's just the units that's squared. It's not 66 squared, just 66 centimeters squared. So this is a quadratic equation, which we can easily solve. So let's do so on the next page. So then S is equal to 22 centimeters plus or minus the square root of 22 centimeters, the entire thing squared, minus 4 times 66 centimeters squared. And then we have this entire thing divided by 2. So we'll get two roots, one that corresponds to the plus sign and one that corresponds to the minus sign. So let's call them S1 and S2. So then I get, for the plus sign, we'll designate that as S1. I get 18.42 centimeters. And then for S2, I have 3.58 centimeters. And I can immediately find S prime. Remember that S prime was equal to 22 centimeters minus S. So from here, if I substitute S1 into this equation, then I get S1 primed is 3.58 centimeters, and S2 primed is 18.42 centimeters. Anyway, so S1 and S2 would be the location, the two different locations of the lens from the object. So we've solved here part A, and we need S1 and S2 prime in order to do part B, which is the magnification. So we can use equation 34.17, which tells you that the magnification is equal to minus S primed over S. So let's call M1, which is the magnification associated with this S1 and S1 prime. So when the lens is 18.42 centimeters from the object, we have minus 3.58 centimeters divided by 18.42 centimeters, and that's equal to minus 0.19. And we do the same thing for M2, which is minus 18.42 centimeters divided by 3.58 centimeters. And that's equal to negative 5.14.